this comes from some really fascinating research that's come out lately. And there's a part of the brain at the back of the brain that sits underneath the brain called the cerebellum. We've known for a long time that this part of the brain automates physical processes. You know, Roger Federer is training that part of the brain to hit tennis balls really effectively, because what it does is it automates processes, and it does so by being very fast and very efficient. So you don't have to think. So notoriously in sport, if you're thinking about your move, you're messing up your move. If you're not thinking, you're just trusting your body to do it, you're much better. That's literally us using our cerebellums. And that works because the cerebellum is super dense, highly connected. It's got actually 80% of the neurons in your brain in there, and it's tiny compared to the rest of the brain. But here's where it gets interesting for neurodiversity, because the evidence seems to suggest that the cerebellum doesn't function the same if you've got neurodiversity. So it's not encoding stuff. It's not automating things that neurotypical people are automating. And if you can't automate it, your brain has two options. One is to think about it using your neocortex. Now, if you do that, you will think about it consciously. You will be more aware of it. Your ability to do it or think about it or reason about it will be much higher. Like, you're capable of being a genius at that. But it's slower and it uses huge amounts of energy. So it's really exhausting. Like, people with ASD, their cerebellums often don't do social stuff, which means that they have to think about social stuff, which means it's slower and they're kind of like drowning in the possibilities. Neurotypical people do not think about doing social stuff. They just run their cerebellar scripts and they just do it. They just, whatever the script says, you do that. They don't think, whereas autistic people actively think. And you can see how difficult that is, because social stuff is really hard and complex, and people with ASD drown in the possibilities because they're doing it with their neocortex. So that's a really good way of showing that. So the other thing is, if you don't think about it, your brain has only one choice. Don't do it. If you can't automate it and you can't think about it, your brain just ignores it. It just goes, yeah, we're not doing that. We give up on that. If you were to give up, or your brain makes like the trade-off of saying, hey, I'm not doing that. If the trade-off was around your physical stuff, you would get the label dyspraxia. If your trade-off was around super short-term working memory, you would struggle to do things like write and read, and we call that dyslexia. ADHD looks like it's long-term, where you're basically going, hey, I'm not doing long-term time, like planning and stuff. I don't need to do that. I need to do now. That's ADHD. It's social stuff, that would seem to be ASD. What they all have in common is that the cerebellum isn't automating something that neurotypicals automate. Depending on the exact trade-off that your brain is making, which thing it stops doing, that is where you get a deficit. If you know your spiky profiles, the thing that you're really good at, that's the thing that you focused on. That's the thing that your brain would said, hey, I can't automate this, but I love it, so I'm going to be really interested in it. And that's where you can become a genius at something. So it's kind of like a bit of both. And there's like, I'll do another video on like the causes, like why the cerebellum does these trade-offs in the first place. Like, why do neurotypicals not do these trade-offs? And why do people with neurodiversity do these trade-offs? That's another video.